Ever found yourself, wishing you just knew if your pet was okay? Not just when they're obviously sick, but like moment to moment.
Mm.
For so many of us, pet care is, well, it's reactive, isn't it? We kind of wait until something seems off. But what if we could flip that? Be truly proactive. Today, we're diving deep into a fascinating proposal. It's an architecture for a pet sensor real-time tracking system designed for a major organization focused on animal well-being. And this isn't just about finding a lost dog, although that's part of it. It's about totally transforming how we monitor and care for them, moving way beyond just reacting.
Absolutely. The vision here is to take pet monitoring from what's often, let's face it, a bunch of disconnected data points, maybe some sensor info here, vet notes there, and turn it into a single intelligence system, a unified ecosystem. Our goal in this deep dive is really to show you how this allows everyone, owners, vets, the organization, to act faster, understand things much more deeply, and importantly, scale up as needed. It's all about getting actionable insights, making timely interventions possible for our pets, giving them the best shot at staying healthy.
Okay, so to really get why this is such a big deal, let's paint the picture of what it's replacing. What was the before scenario like for pet care data? What were those big limitations?
Well, historically, it was pretty fragmented. You'd have sensor data from a collar, maybe logs from a mobile app, vet records, often living in completely separate worlds, silos, basically. Very little integration. And the big problem with that, delayed insights, often really delayed. Think about sensor data. Often it was processed in near batch cycles, maybe every few hours, maybe longer.
So if something urgent happened, like a health scare or the pet getting out.
Exactly. You might not know for hours, way too late for immediate action. Right. And beyond that, the older systems, they really struggled to scale. As more pets got wearables, the infrastructure just couldn't keep up efficiently. Plus, they mostly lacked sophisticated predictive abilities. You couldn't really do proactive care based on forecasting potential issues. And the reporting, it was almost always looking backwards. Retrospective. Here's what happened yesterday or last week. No live dashboards, no real-time alerts as things were unfolding.
Yeah. A reactive approach, giving you info after the event.
Pretty much information after the fact.
So a real patchwork. Slow, couldn't grow easily. Sounds frustrating. Okay, now for the exciting part. How does this new proposed system fix all that? What's the after vision?
Right. The core idea is this unified data platform. It's designed to seamlessly pull in both real-time streaming data and batch data, like those vet records, all into one place, a Databricks ecosystem, using a technology called Delta Lake.
Delta Lake.
Yeah, and this setup allows for real-time processing of that sensor data using something called Spark structured streaming. That's the key to getting instant activity and health insights, not hours later, instantly.
And for the pet owner, what does that translate to?
Well, first, much better scalability. Databricks uses auto-scaling clusters, and Delta Lake optimizes storage so it can handle, millions of pets sending data without breaking a sweat. But maybe the most critical part is the machine learning integration.
The AI aspect.
Yeah, exactly. Real-time anomaly detection, behavioral modeling. This is what enables that proactive care, spotting subtle changes that might indicate a problem early on. And you, the owner, would get access to live dashboards. See what's happening right now? Plus, alerts. Push notifications straight to your phone if something needs attention.
That's a world away from static reports.
Totally. Much better engagement, much faster response times.
Proactive care for pets. That really does feel like a game changer. Okay, so let's get into the nuts and bolts. How does this intelligent system actually work? Where's all this crucial data coming from?
It starts with a few key sources. Each plays a vital role. First up, pet wearables. These are really the main engine for real-time data. Collars, tags, whatever they might be, they're collecting telemetry data constantly. Things like GPS location, obviously, but also activity levels. Are they running, sleeping, walking, even temperature, maybe other health parameters depending on the device.
And that data streams in continuously.
Yeah, streams in via robust tech like Kafka or event hubs, designed to handle huge volumes reliably. Think potentially millions of devices sending data points every few seconds. Then you have the mobile app or API. This is where the owner actively contributes.
Like logging food intake or noting symptoms.
Exactly. Daily logs, feedback, manual health inputs, plus the app itself might provide some additional location tracking when it's open. And finally, veterinary clinics, they provide the more periodic historical context.
Their electronic health records, things like that.
Right. EHR data, results from checkups, medical history. This stuff usually comes in batches, maybe daily, maybe weekly. It doesn't need that second-by-second immediacy.
Okay, so you've got this mix of data. Continuous streams, user inputs, batch files from vets. How does it all get wrangled and stored so it's actually useful and, reliable?
That's where Databricks comes in again, handling the processing at scale. The real-time sensor data. That gets processed by Spark structured streaming as it arrives. Instant analysis. The mobile app data and vet records, since they're often less time-sensitive or arrive in chunks, they go through batch ETL processes. ETL is extract, transform, load.
Just cleaning it up and organizing it.
Pretty much. Standardizing formats, cleaning out errors, and really importantly, before anything gets stored long-term, there are crucial data cleansing and schema validation steps.
Making sure everything's consistent.
Exactly. You need to know that temperature always means the same unit, recorded the same way, for instance. Ensures reliability. After processing, this clean data flows into that Delta Lake storage system we mentioned, and it's typically organized in layers: bronze, silver, and gold.
Okay, break those down for me. Bronze.
Bronze is basically the landing zone. Raw data, just as it came from the source, but maybe with some basic partitioning. It's your archive, your source of truth.
Untouched, mostly.
Right. Then the silver layer. This is where the data gets cleaned, structured, maybe enriched, location data standardized to lat long. Activities categorized. It's consistent, reliable, ready for analysis, much more usable than bronze.
Okay, cleaned and structured. And gold.
Gold layers for the really high-value aggregated data, ready for business intelligence and analytics. Think pre-calculated summaries.
Like average daily steps for my dog.
Exactly. Or maybe average activity levels for all dogs of a certain breed in a specific region. Things that dashboards and ML models can query really, really quickly. This layered approach, especially gold, allows for those powerful, broader insights. Vets could potentially spot health trends across thousands of pets that you just never see looking at one animal. Could lead to new preventative strategies.
Wow. Okay, so the data's ingested, cleaned, beautifully organized in these layers. What comes at the other end? What are the actual outputs that help owners and vets?
Several key outputs really focused on actionability. First, those real-time dashboards. You, the owner or the vet, can see live tracking, movement trends, activity levels, maybe even spot anomalies visually, using tools like Databricks, SQL dashboards, or maybe Power BI, Tableau. It's a live window.
Always on, always current.
Right. Then there's the machine learning inference. This is huge. Deployed ML models constantly analyze the incoming data streams. They're looking for anomalies, predicting behaviors. So if your pet's activity suddenly tanks, or their sleep pattern gets really weird over a few days,
the system flags it automatically.
Precisely. Even subtle shifts that a human might miss initially. For example, a slight but persistent increase in nighttime restlessness over a week. That could be an early indicator. And when it flags something significant, that triggers alerts and notifications.
Straight to my phone.
Yep. Push notifications via services like Firebase Cloud Messaging. Could be a geofence breach, your dog left the yard, or a potential health concern, unusual temperature pattern detected.
That's immediate actionability right there.
Absolutely. And finally, it's not just about real time. There's also historical trend analysis. Vets and owners can dig into the past data, generate detailed health reports, look at long-term activity trends, compare their pet to benchmarks. It's vital for managing chronic conditions or just understanding long-term well-being.
So if my normally very active dog suddenly becomes lethargic, I could get an alert almost immediately. That feels like a massive step forward for catching problems early. But okay, with all this data, especially sensitive health data, how do you ensure it's all trustworthy? How is reliability and, governance handled?
Yeah, super important question. The system has strong features built in for this. A key one is Delta Lake time travel.
Time travel. Sounds sci-fi.
Kinda. But it's practical. It means you can query the data as it existed at any point in the past. Imagine a vet wants to see exactly what a pet's activity levels were before they started a new medication 3 weeks ago. Time travel lets them do that.
So you can audit changes, see historical states.
Exactly. Full traceability. It builds huge trust because you can always verify the data's history, no black boxes. And alongside that, you have Databricks jobs orchestrating the whole pipeline. These are automated workflows that schedule the data processing, monitor the health of the streaming pipelines, handle error reporting, manage alerts, basically ensuring the whole system runs smoothly and reliably 24/7.
Okay, that time travel feature.
Yeah.
Being able to rewind the data,
Yeah.
essentially. That does sound like it builds incredible confidence for everyone involved. Owners, vets. So let's wrap this up. What's the big takeaway for you listening right now? We've really explored how this pet sensor real-time tracking system uses some pretty advanced data architecture to
Hmm.
shift pet care, moving it away from just reacting when something's wrong to being genuinely proactive,
Yeah.
giving owners and vets really powerful new tools for our furry family members' well-being.
Yeah, it's a fantastic example, isn't it? How bringing together different data sources, processing them in real time, and layering on machine intelligence.
Yeah.
How that creates this smart ecosystem, one that delivers timely insights, enables quick interventions, and really fundamentally changes how we look after our pets. It's a level of preventative insight we just haven't had before.
It really underscores how powerful data can be, doesn't it? Not just for big corporations, but for something so personal, so emotional as the health of our animals. And it makes you think, what if this kind of intelligent, real-time insight used so effectively here for pets? What if we could apply that more broadly
Hmm.
to other parts of our own lives? What other possibilities for proactive care, for deeper connection might that unlock?